Okay, hello everyone. In this video, we are going to discuss derivation of Lagrange equation from D'Alembert's principle. So let's start. Consider a dynamic system consists of a number of particles. To specify the configuration of the dynamics of the system, let the independent coordinates or the so-called generalized coordinates or degrees of freedom are q1, q2, qn up to qf, small f, that is your f is nothing but your degree of freedom. These things already we know. Now the position of ith particle of this dynamic system is represented by transformation equation is this one Ri, which is the function of all the generalized coordinates q1, q2, q3, qk up to qn. Here we consider f equal to n and also t. So this is the equation which represents the position vector of ith particle, any particle of this system which contains a number of particles. And here why it is function of t, because as it is dynamics, so we if we are going to consider suppose velocity, then the rate of change of your position vector. So here position also changes with respect to time, hence as it is dynamic system, so hence also this position vector also function of time t. Let this is your equation number 1. The velocity of ith particle will be, we have to take the time derivative of this equation number 1, that is your dri by dt, which will be equal to del ri by del q1 into dq1 by dt plus del ri by del q2 into dq2 by dt and so on, del ri by del qk into dqk by dt and so on, del ri by del qn dqn by dt plus del ri by del t. Okay, so separately we have been differentiated this ri with respect to all the generalized coordinates and with respect to time also. Hence vi, which is nothing but your here d ri by dt, can be written as ri dot equal to this right hand side of the terms which are added can be written in the summation format, that is your del ri by del qk into qk dot plus del ri by del t in the summation format. So here if we are going to consider k equal to 1, then this will be del ri by del q1 and this one is your q1 dot, that means dq1 by dt and so on, and last term written as such. Let this is your equation number 2. From equation number 1, here from equation number 1 we can found the virtual displacement will be delta ri. Here ri is this one, delta ri will be how much, del ri by del q1 into delta q1 plus del ri by del q2 into delta q2 and so on, del ri by del qn into delta qn. So in summation format this can be written as summation over k del ri by del qk into delta qk. If you are going to open the summation, then first you if you put 1, then this will be del ri by del q1 delta q1 and so on. Let this is your equation number 1 3 sorry equation number 3. So equation number 1 represents the ith particles uh, position. Equation number 2 represents the ith particle, the velocity, and equation of number 3 represents the virtual displacement of ith particle. Okay, now we are going to consider D'Alembert principle, that we know that summation of fi minus pi dot, this is pi dot into delta ri equal to 0. This is your virtual displacement, and this fi is nothing but your external applied force on ith particle, and this pi dot is your rate of change of linear momentum of ith particle, subtraction of both, dot product with virtual displacement. If I will consider all the particle which are inside the system will be equal to 0. This is nothing but your D'Alembert principle. So this can be written as summation over fi dot delta ri minus summation over pi dot dot product delta Ri equal to 0. Let this is your equation number 4. Okay. Okay. Now we are going to consider this term only. But summation over Fi dot delta Ri equal to Fi dot Fi into, this is the dot product, okay, into scalar product summation over this one. See, delta Ri already we found in our equation number 3. This one I have been substituted over there. So this one, instead of delta Ri, substituted this much from equation number 3. So that implies Fi dot product with delta Ri equal to written as Qk dot product with into delta Qk. So here dot means product, okay, there is no vector product here, only no need to write the dot itself, okay, no problem. Qk into delta Qk, in this way we have to read Qk into delta Qk. Let this is your equation number 5, and here Qk we considered Fi dot delta Ri by delta del Ri by del Qk. Here this term Fi dot delta Ri by del Qk is considered as capital K, capital Qk, which represents the component of generalized force associated with the generalized coordinates. Okay. Okay. Now we are going to consider second term, this one, that is your summation over I pi dot into dot okay, dot product or scalar product with delta Ri equal to, we can write here, this is nothing but rate of change of momentum, that means m v rate of change of momentum, that means m v dot, or we can write m r double dot, same thing it has been written. So summation over mi ri double dot product with summation over del Ri we found in the equation number 3, just substituted. So the equation number 3 value, this one substituted over here, okay, here, okay. So that implies this one pi dot scalar product with delta Ri will be equal to, here you can see that this summation taken at the initial and summation over I mi ri double dot product with delta del Ri by del Qi whole into delta Qk. This delta Qk will be this one. Let this is your equation number 6. Now we have to consider d by dt of mi ri dot product with delta Ri by del Qk. Here this is means dot product, okay. So this will be how much? Here we are going to consider the product formula. Mi, when this Ri dot is going to be derived with respect to t, then it will be Ri double dot, and this is your second term, as such we have to write del Ri by del Qk plus mi Ri dot, and this one is going to be derivative with respect to t, d by dt of this one, okay. So that implies this term will be equal to this term minus this term, same thing it has been written, okay, d by dt of mi ri dot product with delta Ri by delta Qk minus this term, okay, mi ri dot product with d by dt of delta Ri by del Qk. Then equation number 6 will be, now this equation number, instead of this one we can write this much, okay. Here you can see mi ri double dot delta Ri by delta Qk. So instead of this much we can write this one for equation number 6. So equation number 6 will be, that implies pi dot product with delta Ri equal to summation over k whole into summation over I d by dt of this one, this much we have to write, this much, okay, this much, and finally we have to write delta Qk. So this much into delta Qk. Here you can see that Ri dot is nothing but Vi, Okay, because d by dx by dt, x dot r dot is nothing but dr by dt. So here ri dot ri dot means dr by dt, or this is the so-called velocity. We can write v. So ri dot can be written as velocity vi, and this term written as such minus here ri dot written as vi d by dt of same term written as such delta qk. Okay, that implies pi dot product with delta ri will be equal to summation over k. Here you can see that d by dt of mi vi dot product with delta vi by delta qk dot. This is most important. Carefully you have to write your note. Here this term is written as d by dt mi vi dot product scalar product. Here delta ri by delta qk written as delta vi by delta del qk dot. How it is I will explain. Minus here mi vi is the dot product or scalar product with, here instead of this one we have been written del vi by del qk. How it is? From equation number 2, where is your equation number 2? This one. Equation number 2 is this one. Okay, so this equation number 2, del vi by del qk dot will be equal to del ri by del qk. How it is? This is your equation number 2, no? If I will differentiate this equation number 2 with respect to qk dot, then del vi by del qk dot right hand side will be differentiated with this term, and we can found del ri by del qk, and this term will be act as a constant for the del qk dot, so this term will be 0. So del vi by del qk dot will be this much, summation over del ri by del qk. Okay, same thing it has been written, summation over k del ri by del qk is nothing but del vi by del qk dot. So here del ri by del qk is written as del vi by del qk dot. Okay, derived from equation number 2. Likewise, d by dt of here d by dt of del ri by del qk written as this one. How? Here this is the partial derivative, so I can take del qk this side. Here you can see d by dt of this one, no? So here del qk taken outside, so it will be del ri by del t, dri by dt. So here dri by dt, the rate of change of the position vector is nothing but vi, so del vi by del qk. Okay, so so we found this term will be this one and this term will be this one into delta qk. So that implies pi dot delta ri, pi dot scalar product with delta ri is equal to summation over k this much. This term written as this one and this term written as this one. Okay, and delta qk finally multiplied here also delta qk. So here you can see if I will differentiate this one with respect to delta qk dot, I can found also same term. How it is? Here you can see vi dot vi is nothing but vi square. So when it will be differentiated with del by del qk dot, I can found how much 2 vi into del vi by del qk dot, right? So here 2 and this 2 will be cancelled out. Finally we found mi vi del vi by del qk dot, this one, and d by dt is there. Okay, similarly if I will differentiate this term, here vi will be vi square, and differentiated with the del qk, we can found 2 vi into del vi by del qk, and here 2 got cancel, and we found mi del vi mi into vi, uh, dot del vi by del qk. Okay, so now summation over I pi dot delta ri will be equal to, here we consider that half mi vi dot vi is equal to t. Okay, this is represents the kinetic energy of the system, total kinetic energy. Summation is the total kinetic energy of all the particles of the system. So half mi vi means vi square. So this expression is considered as t, belongs to your kinetic energy. So hence this equation will be summation over k d by dt. Instead of this one we written t or del t by del qk dot minus del qk del by del qk of t whole into delta k. I suggest here that carefully you have to put the dots. Okay, if you miss it, if you are going to miss the dot, no, the physical meaning will be changed. So carefully you have to put the dots. So let this is your equation number 7 and this equation is your equation number 8. Now we are going to put 5 and 7, this one, this 7 and 5, this 5 in equation number 4. So here instead of this one we have to put this one, instead of this one we have to put equation number 7, this one. So we found that summation over k qk delta qk minus summation over k d by dt of del capital T by del qk dot minus del t by del qk whole into delta k equal to 0. So summation we can take common for these two terms, d by dt of delta t by delta qk dot here minus delta t by delta qk, and this will be minus qk delta qk. That means here if I am going to multiply minus LHS and RHS, then this term will be plus here and this term will be minus. Simple. This is your equation number 9. We know that virtual displacement, that is delta qk, are independent with each other. They are not dependent. That means delta qk could not be 0. So if this equation number 9 will be holds good, so to satisfy the equation number 9, all the coefficients of this virtual displacement should be vanish or should be 0. Same thing it has been written. We know that virtual displacements, that is your delta qk, are independent with each other. So to satisfy the equation number 9, the coefficients of delta qk has to vanish separately. That means this bracket term has to vanish, will be 0. Okay, that implies d by dt of delta t by delta qk dot minus delta t by delta qk equal to capital qk. Let this is your equation number 10, and this equation number 10 represents the general form of Lagrange equations. Here the number of equations depends upon the number of generalized coordinates. Here you can see the k value will be increased, the number of equations of Lagrange will be increased. Okay, so if the question will be asked for 6 mark, you have to 6 to 8 mark, you have to write up to this much from here. Okay, from here you practice it well, and may you can omit some steps from this derivation. Okay, don't worry, I'll be upload this note, you can download, link I'll be given in the description, right? Okay, now this equation number 10 is your general form of Lagrange equations. Now we are going to go for the two systems. One is your conservative system. What will be the Lagrange equations, and for non-conservative system, what will the equations? Lagrange equations. Okay. First, we are going to go for the conservative system. It is well known that for a conservative system, the force on a particle can be derived by considering negative gradient of a scalar function, that is your capital U, that is F equal to minus del U. Now consider a conservative system consists of large number of particles. The forces on each particle can be written as Fi, that means force on the ith particle will be this one, negative gradient of a scalar function or scalar potential. U will be written as minus I cap del U by, this is capital U, okay, del xi plus j cap del U by del yi plus k cap del U by del zi. So here I can say one thing, that this U, some books they have written as capital V. So here I used a capital U because for velocity we have been used V symbol. So may it will be confused. So only for that I used capital U. Okay, but some books are written capital V itself. Okay, so therefore generalized force will be represented as, generalized force we have been written over here QK, uh, capital QK, this one, equation number 5. Just after equation number 5, Fi dot del Ri by del Qk. So Qk, this one will be how much? This will be minus, this value will be minus this much, uh, summation over I, this one, I cap del u by del xi plus j cap del u by del yi plus k cap del u by del zi dot del Ri by del Qk. So instead of Fi, I substituted this value and this value, as such it has been written. So if I am going to take the dot product, then of this term and this term, I am going to get this one. So minus is there, minus summation over I del u by del xi, here is there I cap. Here one thing I am going to say, that here Ri is here. Ri is nothing but I cap x plus j cap y plus k cap z. So whenever we are going to consider this term is going to be dot product with this term, then only x term uh, will be multiplied with this del u by del xi, and other terms will be cancelled out because Ri is nothing but I cap x. Okay, so here I'm going to show you del Ri by del Qk. So here del x by del Qk, del y by del Qk will be there. So whenever it will be dot product with mm, I cap del u by del x, then I cap dot I cap, only these two terms will be going to be multiplied and other terms will be cancelled out. So del u by del xi into del x by del q k plus, similarly for the y term will be del u by del yi into del yi by del qk plus del u by del zi by del qk. So we found qk equal to this much, and here we have to remember that this potential or scalar function is the function of only position of the particle or the coordinates of the particle. So for the three-dimensional case, the u is the function of x, y, z, or for ith particle it will be xi, yi, zi. So this u is the function of x, y, z, or ith particle it will be xi, yi, zi for three-dimensional case. So now if we are going to consider del u by del qk, then this can be written as del u by del xi into del xi by del qk plus del u by del yi into del yi by del qk, del u by del zi into del zi by del qk. So in general we can write qk equal to minus del u by del qk. Now the equation number 10, this equation 10 will be here qk, instead of qk, capital Qk, we can substitute this value. Okay, so here I substituted minus del u by del qk. Okay, so this is minus, if I will take this side it will plus, and this is minus del t by del qk, and this will be plus del u by del qk. So if I'll take minus common, then it can be written as del by del qk of t minus u. Okay, same thing it has been written. Now the equation number 10 will be d by dt of del t by del qk dot minus del by del qk of t minus u equal to 0. Let this is your equation number 11. And here you can see that u is the function of only positions, not velocity. Hence, if I am going to consider del u by del qk dot, then obviously this value will be 0. So here, if instead of t I will write t minus u, so there is no change I can found, because whenever I am going to derivative differentiate this one t minus u with respect to del by del qk dot, then now we can found del t by del qk dot, because u will be act as constant for qk dot, because u is the function of only position coordinates. Okay, so this equation number 11 can be written as d by dt of del by del qk dot. Instead of t, also we can write t minus u minus this term equal to 0. Let this is your equation number 12. Now we considered here L equal to t minus u, which is called as the Lagrangian. Okay, so hence equation number 12. Instead of t minus u, we can substitute L, d by dt of del L by del qk dot minus del L by del qk equal to 0. This is the Lagrange equation for conservative system. Now we are going to go for Lagrange equations for non-conservative system. In case of non-conservative system, the scalar potential or the scalar function is a function of both position and velocity, like this. So generalized forces are to be represented by minus del u by del qk plus d by dt of del u by del qk dot. Now the equation number 10 will be, so here instead of qk in your equation number 10, we have to substitute this value. Okay, so this will be equation number 10 will be d by dt of del t by del qk dot minus del t by del qk equal to this one. These two terms taken to the left hand side, and we found here d by dt of this one minus del t by del qk here, and here this term is here minus d by dt of del u by del qk dot, and here this minus term will be plus del u by del qk equal to 0, and these two terms can be written as d by dt, d by dt, d by dt is there, del by del qk dot, del by both are same, into t minus v, or del by del qk dot of t minus v minus of del by del qk of t minus u equal to 0. Here t minus u. Okay, let this is your equation number 14, and here we considered as t minus u your L, so this equation can be written as d by dt of del L by del qk dot minus del L by del qk equal to 0, equation number 15. So 14 and 15 both are represents the Lagrange equation for non-conservative system. Here we have to remember one thing, that for non-conservative system, L or your so-called Lagrange is a function of q and q dot, position and velocity, but in case of conservative system, Lagrange is the function of only position. Okay, because the potential is the independent of qk dot for your non-conservative system. Okay, for the conservative system, Lagrange is the function of only position, but here In this case, conservative case, it is the function of both position and velocity. So for the 10 mark question, if asked that you have to derive the Lagrange equations from the D'Alembert principle, you have to derive up to equation number 10. And then after these two equations, these are two equations, that is your equation number 13 and equation number 14 or 15 are the special cases. Okay. So thank you so much for watching this video. I'll upload this note, link given in the description, you can download. Thank you.